What's up, YouTube? My name's Luke and this is my FanucPegandRing project. Before we start, just a reminder to smash that thumbs up button and subscribe to the channel. So today, I'm going to be explaining what my project is and how I put it together to work how it is in the video. So as you can see, there's a lot going on. There's a lot of sensors involved. There's only 4 outputs in my program. So there's the 2 conveyors, the chain conveyor and the belt conveyor. There's a spring return and there's a solenoid. So the first output, the solenoid, there's 2 sensors right next to that determine whether a ring is present or a peg is present. If the ring is present, the solenoid will fire and send the ring down to the spring return. And the spring return will be energized as long as there's not another ring below it, which is sensed by the photosensor. So as you can see, that one just dropped in because the sensor sensed that there was nothing there, so the spring return was energized. The most challenging part about this project was programming the robot. I used a teach pendant to tell the robot which movements I wanted it to do. The robot either needed to pick up a ring or pick up a peg, or both. To get it to do this automatically, I had to send a bit from my PLC to the robot program to tell it which motion to do. One of the problems I ran into with this project was when the objects on the belt conveyor got stacked up at the end. When this happened, the robot would sometimes run into them, triggering the e-stop. To fix this, I made a few tweaks with my program to stop the belt conveyor or the chain conveyor for a certain amount of time as the robot picks up the objects and moves it over. Once it drops them, the chain conveyor will continue to move until it is ready for another object to be placed on it. Now that I have explained the basic function of my project, please enjoy the next few minutes of my program in action. This is my e-stop, reset, start and stop push buttons and a green light to tell whether the project is running or not. The e-stop, when pressed, will cut power to the entire process. To be reset, it must be pulled out and the reset button needs to be pressed again. The start button will start the entire process and the stop button will shut down all the outputs. When the green light is on, it means the process is running, and when it's off, it is off. The robot can also be e-stopped by opening the door of the enclosure. Doing this will not shut down the conveyors. This is the first screen you will see when you open the HMI. is the login screen where there's 3 separate users: maintenance, supervisor, and operator. Each of them has different capabilities and different screens they can see. As you can see here, the maintenance guy cannot see the main screen, only the alarms and trends. Here you can see the trends page on the HMI working as the program runs. The trends page is set up to see the belt conveyor, the chain conveyor, and system enable. By doing this, you'll be able to tell whether the conveyors are running or not, and if the system is enabled. This page could be used for troubleshooting by the maintenance guy. Here I am logging in as a supervisor so I can access every page in the HMI. This is the main screen of the HMI. I have the 2 conveyors with pegs and rings on them, the sensor that tells the robot whether or not to pick up something, and of course the robot. So the green light in the left hand corner is the system enable light, which tells you whether or not the start button is pressed. The robot turns green when it is in motion, and the peg blinks on and off when there is an object at the final sensor.